Welcome back, everybody. The lecture today is going to cover two topics. The first one is on the shorter side. We're going to discuss hypothesis testing errors. While we can run hypothesis tests, basically we're basing our decisions on whether to reject or fail to reject the null hypothesis on some sample data. Now, if we just so happen to pick a bad sample, we may end up being led to the wrong conclusion. So we're going to talk about what kind of errors we could make by doing our hypothesis testing process, and we'll talk about some terms involved in those particular errors. We're then going to move on to another example of a hypothesis test that we can do. In this one, it's going to compare populations. Specifically, we're going to look at a way to use Excel to test claims about whether or not two different populations have different population means. Let's get started. Let's consider the types of errors or types of mistakes that we could make in running a hypothesis test. I have a little table here that sort of lays out the different types of errors or different types of mistakes we could make by running a hypothesis test. Now, in the rows, we have the two possible conclusions that we could come to after running a hypothesis test. Remember, those conclusions are either we reject the null hypothesis or we fail to reject the null hypothesis. Now, we can always compare this to this sort of thought experiment type of approach where what if we knew the true population parameter and we could say whether or not H0 is true or false, right? So we can compare what our hypothesis test is telling us to do. Remember, this is a decision based on data. We can compare what our hypothesis test tells us to do based on what the possible truth is behind that null hypothesis in reality. So, for example, if I run a hypothesis test and it tells me to reject my null hypothesis, and in fact, collecting all the population information, we found out that null hypothesis is false, well then this is really just great news because that means I came to the correct decision, right? What I'm having here is an agreement between what my test results, remember this is a decision based on a sample, I have the correct test result with what's actually happening in the population, okay? Unfortunately, it's possible, since we're only looking at a sample when we do these hypothesis tests, it's possible that the particular sample we collect just happens to be unlucky enough that it tells us to reject H0 when in fact our null hypothesis is true. And if that happens to be the case, we end up making a mistake. We have incorrectly rejected that null hypothesis by trusting data that just so happened to be an unlucky representative of what's going on in the population. We call these type 1 errors when we reject H0 based on the sample we collected, but in reality, we're making a mistake in doing that. If we could access all that population information, we would find out the null hypothesis is true. So this is one type of error that we can make. The test tells us to reject the null hypothesis, and if we're making a mistake, that means that in the population, the null hypothesis is actually true. So this is called a type 1 error. And I want you to associate this to our significance level alpha, because we're going to see a connection to this very soon. The other way that we could make a mistake is depends on getting the opposite result for our hypothesis test. So suppose we collect some data and we end up getting a p-value that's above our significance level. So we in fact don't reject the null hypothesis. We fail to reject the null hypothesis. So our data is telling us to fail to reject. Now, if in the population, the null hypothesis is actually true, then the hypothesis test worked. We ended up coming to the correct decision. No mistakes here. This is good news. But it is possible that the sample that we collected is an unlucky sample, and it tells us to fail to reject H0 when in fact the null hypothesis really should be rejected. This is what we call a type 2 error, and it's related to another Greek letter called beta. A good way to remember these two different types of errors for hypothesis testing is to lean on our analogy to the criminal justice system. So remember, in this analogy, we sort of treat the null hypothesis as being the defendant, the person on trial. All right? And so we interpret this idea of the null hypothesis being true as essentially meaning that the defendant is innocent. So I'm just going to start to kind of revise my table slightly. And the null hypothesis as being false is equivalent to essentially our defendant being guilty. Now, in the role of our hypothesis test, this is sort of what the jury makes a final decision about. So if the jury decides to reject H0, that's equivalent to the jury saying, oh, the defendant is guilty, so we should send them to jail. All right, so we'll call this jury result, and this would be guilty. And again, this is based on the evidence presented. This is kind of like us making a hypothesis test conclusion based on the sample we collected. Right. Similarly, our other option, the failed to reject, would be the jury deciding, well, we can't decide beyond a reasonable doubt that this person is guilty, so we're just going to have to presume that they're innocent. So our jury result on this side would be innocent. And so now we can kind of see how this ends up playing out, right? In the case where the jury says guilty and the person's actually guilty, well, great news. The criminal justice system worked. Similarly, if the person's actually innocent and the jury says innocent, again, the justice system worked. But you can think about the justice system as having two possible mistakes that it can make. The first mistake is when, in reality, the defendant is innocent, but they're found guilty. So what happens here is an innocent person goes to jail. And this is the idea behind a type 1 error. A true null hypothesis through an unlucky sample gets, our final conclusion ends up being, well, we should reject that null hypothesis. The other mistake the criminal justice system can make is if the jury says somebody is innocent when in fact they're guilty. And that's where we're sitting in this type 2 error situation. So this corresponds to a guilty person going free. And this is the criminal justice analog of a type 2 error. Okay? And again, back to our hypothesis testing, this meant, well, our sample didn't provide us enough evidence to reject H0, but that's because the sample itself was kind of an unlucky one. So we just didn't have enough evidence to reject, even though in fact that null hypothesis truly is false. Okay? So with a magic wand here, I'm going to erase everything that I kind of wrote, and we'll see we're back to our original table. So again, the idea is there are two types of mistakes that we can make. We can either falsely reject a true null hypothesis, or we can fail to reject a false null hypothesis. And these are respectively a type 1 and a type 2 error. So what we're going to do in the next set here is we're going to take a look at examples and we're going to mark out what is our type 1 error, what is our type 2 error for a particular hypothesis test. And what this allows you to do is be aware of the mistakes that you could be making by trusting the data to make a decision about a population. And you should always be aware of the mistakes that you could make by trusting data. It's just responsible use of data.